Hi, Alan. It's very nice to have you back on your second 50 podcast. Thank you so much for coming. I hope you had a good holiday.
Thank you. Wonderful.
So today we're going to talk about the importance of glutathione. And glutathione is, a lot of people know that it's a very powerful antioxidant, but without really knowing a lot about it. I think one of the challenges with glutathione is it is not easy for the body to actually, absorb it, or, it's not something that you can easily take as a pill and just expect that it's going to be a miracle. However, you did find a solution. So far, the way I have been handling glutathione has been when I was doing IVs, and every time I do an IV, usually Myers cocktail or high dose vitamin C, I like to finish with a glutathione push in the IV line. And so that's been my exposure to it. And again, I think it's a super important antioxidant, and I'd like you to tell us more about it. It's its timing is very important for it.
It's my pleasure. And one of the statistics I'd like to put forward right at the start is there's 144 different diseases, most of them which we would attribute to aging. So diabetes, cardiovascular disease, some of these things that we kind of think come along with aging. But there's been 144 different diseases that they all have one thing in common, and that's low levels of glutathione. And then when we looked at octogenarians, the older crowd and the ones who are doing really well, the one thing they have in common, even if they lived in a blue zone, is they have the glutathione levels of, say, a 40-year-old or a younger person. So it is a really powerful antioxidant. As a matter of fact, I trademarked glutathione, the molecule of life. And the reason I did that is if we didn't have glutathione, we could not use oxygen. So if we couldn't use oxygen, we wouldn't be here. Like, it's really simple, right? And as a matter of fact, in the 30s, when the Nobel Prize was given out for the understanding of the power of glutathione, they said that it was coincident with life. In other words, we couldn't have life as we know it today. And that includes plant life and even bacteria. There's just a few bacteria that don't use glutathione, but plants, animals, all mammals, we all have glutathione.
Where do we find it? Like, that's the question. Where do people find glutathione? Can you find it in your nutrition, and where?
Yeah, that's a great question. So there's a lot of research been done. Actually, McGill University in Montreal has been a lead researcher in uncovering the power of glutathione. And they started back in the 70s. So Dr. Gustavo Bunas, who's one of the sort of fathers of the innovation of glutathione, and Dr. Patricia Kahn-Chauvin, who is considered the mother of immunology, they were given some protein powder years ago, whey protein powder, and the thought was it was a waste product from the dairy industry, and it was clogging up the sewer systems in Switzerland. And this man who was ahead of his time as an environmentalist, he sent it over and said, is there anything in this that's any good? So they started feeding it to their mice, and they found out that their mice would live 30 to 50% longer. So like, wow, that's incredible to get that kind of extension of life. And of course, rodents, have a very short lifespan. Even in nature, they don't have a long lifespan. You don't find 20-year-old mice. So, they measured that, and they're like surprised. They started doing research and what's in this, and they said, well, it's an organic compound. We can't really identify it, but we know from our research that it's optimizing glutathione. And it's the first thing that they'd ever found. So we would think, well, if we read about glutathione, it comes from cruciferous vegetables. It's actually the amino acid cysteine in those vegetables that's contributing to glutathione. But unfortunately for us as human beings, we don't have a very good transport mechanism for that amino acid. So while we know that that's the rate-limiting amino acid in the production of glutathione, we're not very efficient at doing that. And that's why the drug was made years ago, it's probably 80 years ago, that they acylated that amino acid and came out with N-acetylcysteine. You've probably heard of NAC or N-acetylcysteine. And so that was sort of and that became the foundation for the research into glutathione and the power of glutathione and all the things that it could affect. And essentially what they'd uncovered was it's the master antioxidant. It's not just an antioxidant. So the antioxidant comes in a cascade in our body. So when we say neutralize one thing, that becomes then a free radical. Now we have to neutralize that. So it works usually in cycles. So you have glutathione, vitamin C, and vitamin E that all work together in a cycle to reduce oxidative stress. And the fact is, I remember when antioxidants became really popular in the 90s, everybody was taking antioxidants. They were measuring them by something called an ORAC score.
Yeah, I remember that.
You remember ORAC score? That came from the agricultural industry. It was never something that was tested on humans, but people were taking just huge amount of antioxidants. And in some research, and they all of a sudden saw this sort of corresponding increase in glutathione activity in the body, and they're like, "Oh, what's going on?" Well, as soon as those antioxidants that people were taking were neutralizing a free radical in the body, they became then a free radical and had to be neutralized. So the body was reacting to that. So even herbal preparations today that people say, well, that increases your glutathione 300% or some percentage, that's a reaction to the fact that you've taken an antioxidant, it's neutralized a free radical in the body. Now itself has become a free radical, and it needs glutathione to neutralize that. So great amounts of research have been done on this. And what we discovered actually is if we can get the amino acids, so glutathione is a tripeptide. And for people that can't remember the word glutathione, just think about put your tie on. Put your tie on, glutathione. It's kind of an easy way to remember that. And we found that if we can give those amino acids in a particular ratio, then certain reactions happen in the body without that ratio. So if we just give exogenous glutathione or glutathione that's made outside of our body doesn't recognize that as our own glutathione. So it will actually deconstruct that molecule into the component amino acids, and then you're hoping that somehow that will get reconstructed into glutathione. So exogenous glutathione, like your push and IV, does have some activity in the blood as an antioxidant, but it doesn't have any power to build glutathione in our body. And what I wanted to do is discover if there's a way that we could really optimize our enzymatic genetic process to get glutathione. And that's what all the research at McGill was about, and other people have researched that as well. And it's true that we now can optimize. Now, many people don't know about, you're an odd person that I talk to that knows about glutathione. And the reason that people don't know about it is we get our glutathione when we're born. So hopefully our mom had some glutathione to give us. If she was low on glutathione, then we would be low on glutathione. And people wonder sometimes, well, how is it that infants are born and then at 3 years old they're getting cancer, or they're getting some other really nasty disease, or even autism, the rise in autism. And we did some research back, and I was part of this. We did a clinical trial on infants, and we took the mothers, we put them on a special diet to optimize glutathione, and then we followed up for 4 years after. And in that 4 years, we didn't have one child that developed any kind of childhood disease. So essentially what we were trying to determine is if we can somehow optimize the nutrition in the mother, which will then optimize the nutrition in the fetus, and hopefully give that child a better chance when it comes out. And it's a very small trial. It's only 100 kids, but it was significant in the fact that out of those 100 kids, which we followed for 4 years after, never developed a childhood illness. So,
wow, that's really impressive. So, what kind of markers were you looking at? Like you followed these kids for 4 years. Like what were you looking at in more particular, comparing them to kids that were not in that group?
Well, we're looking for the sort of cognitive difficulties that kids experience now, the ADHD, autism, being on the spectrum, other things like childhood asthma, which is very common.
Very common.
Very common. Childhood diabetes, which unfortunately
it's rising.
It's rising right now. And so we were following these kids. We weren't impacting the kids' diet after they were born. They were kind of in their mother's care.
So the only variable was glutathione.
So the only variable was the fact that we optimized through the use of proteins. We optimized we felt we were optimizing glutathione, and our results then told us that that's what was happening. It's very difficult to measure glutathione levels in the body. Most of it's held in the reduced form, so it's not in an active method, in an active form. So it's difficult. It can be measured. And how we do that is we would take a blood sample, and then we would put it in a solution, and then we would put something that would generally kill those cells by an oxidative process. So some free radical product in there, and time the amount of time that it takes for those cells to die. And then we would take that same batch of cells, put it in a dish, and put some glutathione in there, or solution with the precursor amino acids, and then time the difference between how quickly these cells died compared to how quickly the ones died. And there's a significant difference in that. So that's really the only way we can kind of get a handle on glutathione levels, if we took somebody's blood and put it in some peroxyls and did some complicated things.
So why is it so important for people in their second 50 to maintain a certain level of glutathione in the body?
That is a wonderful question. I'm so glad you asked it, because all the research, no matter where it's done, shows us that around age 40, it's not that our glutathione, it's the recycling of the glutathione that seems to slow down. So our liver contains about 50% of our glutathione. Our lungs, another storage area, our skin, our eyes. So if you think about that, it's kind of a wonderful thing, because if we were going to be infected or invaded, it's sometimes through our skin, through our lungs, through our digestive tract, which the liver is right there, or maybe through our eyes. So to have sort of more optimal levels of glutathione in those areas is really evolutionary, wonderful. It's very, very evolutionary wonderful. And but so we don't know why, but the recycling of the glutathione begins to slow down. Now, I have some theories about that. So remember, these are just my theories. But also around age 40, people start to diet. Generally, they start to be concerned about their weight. The kids are kind of, on their way to be grown up. It's time to take care of myself. I need to go on a diet. And so we see people starting to restrict nutrients in their diet, including antioxidants. Maybe they go on a carnivore diet where they're not eating any vegetables and relying on just meat to get their cysteine from, or some other program like that. So there's kind of an adjustment around age 40 to 50 where people go, they start to think about life differently. And at the same, so we might not be getting the nutrition that we were getting when we were younger. We might not be getting it, or we have such a busy life. We're eating a lot of different, foods. Like, we're not eating whole foods. We're eating a lot of foods from fast food places. So we're just not getting the nutrition. And I feel that plays a big role in it. And one of the things that I know for me as a person in my second 50 is optimizing my protein intake is extremely important. And there's a study that was done at Guelph University that proved that people that were optimizing their protein as they got older tended to be quite a bit more healthy than the people who didn't. So we need to scavenge these amino acids. Our body needs to scavenge these amino acids. And if we're not focused on protein in our diet, so cysteine isn't a popular amino acid in any way, shape, or form in food. So, like, if we were going to say try to optimize glutathione just using food, you'd have to eat about 50 pounds of broccoli a day.
That's a lot of broccoli.
That's a lot of broccoli. Yeah, you'd have to eat a lot of food. And the reason for that is we're competing. Remember, in our intestinal tract, we have a similar number of cells as we do in our whole body. So the bacteria, the microflora in our intestinal tract is very, very populated. And they need that amino acid for their own immune system, for their own functioning. So when we take in food, we're competing, our intestinal tract is competing for the rest of our body for this very scarce amino acid in food. And a lot of it never gets to the intestinal wall. So one of the things we've played around with is how can we make sure that it's going to get to the intestinal wall and get through. And one of the ways to do that is use a bonded molecule of cysteine. So that's called cysteine. It's just two cysteine molecules together. At our cell, at the digestive tract level, that can pass through. It's got the same transport mechanism as cysteine, but it's more efficient because you're getting two molecules. So you're actually getting a 2-for-1 as it crosses the intestinal tract, and it immediately breaks into cysteine. So we don't see the bonded molecule in our blood. Even though we put it into our intestinal tract, when it comes into our blood, it is the single molecule which our body needs. So when that cysteine arrives at a cell membrane, there's receptor sites for these amino acids. Cysteine and glutamate, or glutamic acid, people will say glutamine, glutamate, they're all kind of referring to the same amino acid, right? It's just different forms of it traveling in the body. That's one of the most abundant amino acids in food, so we're never really short of that particular amino acid, glutamate. When those two come to a cell wall, we trigger an enzyme called glutamyl synthetase, and it attaches those two amino acids together. So now we have a glutamate and we have a cysteine together. When that happens, a secondary enzyme is produced, and that secondary enzyme adds glycine, and now we have glutathione. We have this tripeptide, 3 amino acids. The interesting thing about those enzymes, they're from different evolutionary sources. If we look back at protozoa and we look at its single-cell organisms, the glutamyl enzyme came from bacteria, and the other enzyme actually came from protozoa. So, or maybe somewhere else. We're not really 100% confident about that, but they did evolutionarily come from different sources. So to come together in mammals and in plants to provide this antioxidant activity is really amazing. How that ever happened, nobody really knows, but we do know that about them. So we have this very genetically controlled system of production of glutathione. So let's go back to your push. You put glutathione into your blood, right? So it does have some activity in the blood as an antioxidant, but glutathione has other activities we're going to talk about. So it does have some antioxidant activity in the blood. When it comes to the cell level, now remember, if a free amino acid comes to that, it triggers an enzymatic process. When a glutathione comes to your cell wall that isn't your glutathione, there's a 98% resistance to that passing through the cell wall. So people we'll give it as a liposome, right? So attach a fat to it, and hopefully that'll get it across the membrane. And it does get it across the membrane, but it's still bypassing the enzymatic process. So it's still not recognized in the cell as your glutathione. So while it might have some minor antioxidant activity inside the cell, it's still not your glutathione, and most of it's going to get destroyed. And then we don't really know what happens to those amino acids once they're in the cell.
So how would you fool your body by taking a supplement that the body will think that it is my own?
So there's two ways to do that. One is like N-acetylcysteine, which is that's a drug, and many people don't know that it's actually a drug because it's sold NAC, everywhere, right? But
NAC.
Yeah, NAC.
Yeah, which I've been taking.
So it's actually a Schedule II drug in British Columbia. It's a Schedule II drug in most provinces in Canada. And recently, January of 2023, the FDA kind of limited the distribution of it because
they let it happen again now.
Yes, and you can use the ethyl ester and a couple of other different formulations of takeoff of N-acetylcysteine. But the reason they actually wanted to limit it is because our body, because it's a drug and it goes to your liver, gets metabolized, you get used to it very quickly. So people were taking very large doses of it. And there were some complications with that amount of cysteine on our body where there's a toxicity level of cysteine. So that was the FDA's concern. Now, how many times that happened, I don't know. I've never heard of a cysteine overdose. But anyway, that was the FDA's thinking behind that, because there were people taking like hundreds of grams of N-acetylcysteine, which I don't know how they do because it smells so bad. They've got a sulfur smell. It smells like an oil well. But and so do you after you take it. So what we've discovered is if you get the amino acid, the bare amino acids, so like cysteine, and you can put it in different formulas. So there's a formula that's like we have BioImmune on here. That's a formula that I made. I put that in neem and some other different sort of,
You have asparagine,
yes,
neem bark extract, citrus bioflavonoids, limonoid extract. It's a proprietary blend.
yeah. So limonoids are basically fat from plants in a simple, we're making it very simplistic here. So instead of using a liposome, we're using that to transport the amino acids to the cell wall. And also there's some indication from research that the limonoids will trigger the enzymatic process. So not only to deliver the cysteine, we also stimulate the enzyme. There's another formula out there that's an amino acid formula with a little bit of selenium. So they use methyl selenium to do it. Selenomethionine is actually what they use. So they can use that. The most important molecule in this whole thing is sulfur. So we need a lot of sulfur in our body. It's not something that we consume a lot of because our body does retain it, and it can be very toxic to us. But
You find it in like garlic and
yeah, garlic and cruciferous vegetables, or
broccoli maybe, or
yeah, and then that's your broccolis and so on. They're higher in sulfur, but we're talking micro amounts. Like, we're not talking big amounts of sulfur. But we do need it. It's very active. So let's talk about just briefly the other things, because we've only talked about glutathione as an antioxidant, and it is the master. So let's say we fill our body up with other antioxidants. Like I said before, you're going to get an increase in your glutathione because it's going to have to neutralize those as they become free radicals. So taking a ton of antioxidants isn't going to be as useful as just optimizing glutathione. So if you optimize glutathione along with vitamin C and vitamin E, which are the three that they work as a cycle in your body, that's much better than taking a whole handful of antioxidants.
antioxidants. What people take typically, you would say, give us some example. I mean, I take resveratrol.
Yeah, resveratrol.
Nogenol.
You know, the most popular is just a mix of greens.
Yes, well, that's true.
Right. And I think when we look at the chemical composition of most of the greens mixes, there's some alkaloids mixed in with something else, and there's all sorts of chemical compositions in there. I'm not sure. I'm not really confident in the greens mixes that are out there, although they're very popular. I think if you ate a few vegetables, you'd be better off, just quite frankly. But if you optimize glutathione, you'd be much better off because you're making sure you have the master molecule that actually controls the cascade of antioxidant activity in your body. And so there is this cascade. When you reduce one, you get another one, and you have to go down this scale. And that's why they all work in kind of in a cycle of three. And the three most important, glutathione, vitamin C, and vitamin E, for anti-inflammatory activity. But the amino acid cysteine has many activities in the body. So we mentioned the competition with our microflora.
Mm-hmm.
Cysteine also has been shown to stimulate lipolysis in the liver. So that's the redistribution of fat, or the metabolism of fat in our liver. So cysteine can do that. Cysteine is also a major molecule in detoxification. So glutathione is able to neutralize many toxins that come into our body, right? So things like mercury, lead, aluminum, or aluminium, all these different things we're exposed to. Glutathione can actually, through a process in the body, make them into a liquid form, water-soluble form that can actually pass out through our skin or through our kidneys or through the fecal matter. So glutathione, the cysteine, is the major driver of the detoxification. So it's actually the master of the antioxidant function. It's also the master of detoxification function. And that's even a bigger thing. And then it's also the master of inflammation. Along with
inflammation, the cause of so many diseases, most diseases.
The inflammation, yes. In 2004, Time magazine wrote a cover story, Inflammation, the Root Cause of All Disease. It wasn't the root cause of all disease. It was a root symptom of all disease, really. In essence, if we have a disease, we have inflammation somewhere.
I get it.
Yeah, so it's not the inflammation causing the disease.
Good when you need it.
Absolutely.
It's but not chronic inflammation.
Yes.
That's the problem.
Inflammation is a natural process. So if we break a bone, we want inflammation. If we cut our skin, we want that inflammatory. if we get an infection, we do want that natural inflammatory process to rush in and bring all the nutrients and all the, the cells and neutrophils and white blood cells and everything to fight whatever's going on in our body. So we want that, but we want to master that level of inflammation. That's what glutathione does. Glutathione is also responsible for attaching oxygen to our iron molecules, so our hemoglobin. So that's a process that most people
What says.
Yeah. So people, as they get older, tend not to absorb and utilize oxygen, and you see a lot of people with oxygen masks. And if I see somebody that's on oxygen, that's somebody that absolutely needs to be on a glutathione precursor supplement to enable their body to more efficiently attach the oxygen to the red blood cells to carry it around the body. So
anybody can use it. Like, I mean, from kids.
Absolutely.
Seniors.
Infants to whatever age. Yes. We have no way of measuring it in infants.
But somebody's talking about the government. We don't talk about glutathione. We don't hear about, daily intake of glutathione or recommended dosage or anything like that. It seems to be really...
So in the medical literature, and remember, maybe a lot of people don't know how influential McGill University was in what is taught in medical. Yeah. But, before they had Dr. Bunis there, Gustavo Bunis there doing research on glutathione, they had sort of determined that the level of glutathione you get when you're born, that's what you get. You can't do anything about it. It's just the luck of the draw. And so that became the mantra in the medical system. There's no sense, we can't really test for it. There's no sense really trying to look at it or follow through with it. But we now know that we use about a gram of glutathione every day. We have about...
How can you be having enough when just having that reservoir that if you had a mother who had a good level of it, if you are lucky enough, you would have a decent level as a child, but how can that last so many years?
Especially when a lot of people are liver... So recycling happens in the liver, and we know that a high percentage of the population has definitely challenged their liver through their life, through alcohol consumption, through smoking, through toxins in our food, through toxins in our environment. So we're dependent on these so many factors that we see this lowering of glutathione. And really, if I could measure your glutathione level, Ron, I could predict pretty accurately your lifespan. Like, to be honest with you, that's why I called it the molecule of life. Because if we see that going down, it's not very long before those cells apoptose, because there's a process inside the cell that nobody talks about. So why did glutathione, what enabled it to be such a strong antioxidant and actually give the basis for the creation of life as we know it today? Well, it's the process inside the cell. So you think of a single cell, what's its purpose in our body? Like, I don't think anybody really thinks about a cell. What's a single cell's purpose? We think them as an organ.
It'll come from a cell. It's pretty important.
Yeah, right? So inside the cell, basically we make protein, we generate energy, and then we replicate, right? So that's really, an individual cell really has a simple life, if you want to put it that way. It generates protein. Every movement in our body, the color of our hair, everything is protein. It's just a reconfiguration of protein. So we make proteins, right? Yes, we do make some enzymes and so on, but primarily a cell's purpose is to make protein, generate energy, to give us energy to live life, and then to replicate. And hopefully when it replicates, we get two healthy cells from the one that's replicating. So this is where I see the biggest, I'm going to say, gap in information when we're talking about glutathione is we never talk about, healthy cells lead to healthy organs lead to a healthy organism. So if we get right down to what makes glutathione so important and necessary, it's that intercellular process that's going on whereby we can keep that cell healthy. And one of the things we know, like in cancer is a fast growing, a tumor. It's not being controlled by our immune system, so it's growing very fast. And it's actually stealing the glutathione out of surrounding cells. And if we can keep that cell really healthy, then a healthy cell will not give up its glutathione to, say, a cancer cell. It's one of the ways we can actually, I'm going to say, prevent cancer. We can use glutathione in the treatment of various cancers as well. We can't use IV glutathione. We can't use exogenous glutathione because your cancer cells will use that, right?
That's right. They will take it.
But the interesting thing about cancer cells is they're not as efficient at uptaking the amino acids as your healthy cells. So we can, when we optimize glutathione in somebody who has cancer, we can see their healthy cells staying healthier, and the cancer cells tend to wither. And
on that, even on probably doing live blood analysis.
Yes, yeah, you can.
Before, after, and
yeah, and we've seen tumor reductions and so on in people because we're keeping those healthy cells and not giving up their glutathione to the cancer cells. Because cancer cells.
If I would recommend, of course, I am taking the Bioimmune. I am taking your product every morning. What dosage do you recommend to people? How long should they take it for? Of course, they should keep taking it, I think.
Yes, it's something that I would take the rest of my life. I mean, it's just one of those things. I know that my body's using at least 1 gram a day. You know, if you're sick, you're going to use more. If you're under a lot of stress, so stress burns through your glutathione, and there's who isn't under lots of stress these days. So I made that formula so that it replaces 1 gram of glutathione every day. The potential is in there to replace. I can't say that for sure because I don't know anybody's body condition, but I made it so that potentially you could replace that gram of glutathione that you're utilizing every day. Now, just keep in mind, when somebody's on medication, for instance, and that has to be metabolized and then removed from the body. So let's say we're just on something simple like Tylenol. Tylenol is considered really safe and effective until recently. Now they're beginning to question the safety and efficacy of Tylenol because people are consuming it in a huge amount.
Liver and kidney potential issues.
Right. And so 50% of our glutathione is stored in our liver. If we're taking 500 milligrams of Tylenol every 4 to 6 hours in our body, we're occupying about 50% of our glutathione in our liver. So we're actually prohibiting our body from accessing the main storage mechanism for glutathione. And that's why I believe we see, somebody who gets sick and then they get worse. They start off with one disease and then they get another disease. And I wonder sometimes if it's because, we're giving them medications. Those medications need to be metabolized. They need to be excreted. You're occupying your immune system with that process. Right? Instead of allowing your immune system to function as normal and fight whatever the inflammation is in your body and so on. And that's where I think glutathione optimization becomes really important. Is, if you're somebody that's on a whole bunch of medications for different reasons, and people are on for different reasons. The other thing that I'd like to mention is, and this is something that people I don't believe are too aware of, but you have, I'm going to say it's kind of a separate immune system for your brain. So our brain really needs to take care of itself. Your brain is composed essentially of fat and water, a little bit of protein, but it's essentially fat and water. So if we get something in there that's fat soluble, we'd like to get it out of there very quick. So we have a little extra sort of immune function in the brain that's powered by glutathione. And as you get older and we worry about cognition problems, well, that's another reason why I think as we get older, it becomes even more important to optimize glutathione along with exercise, right? And exercise produces brain-derived neurotropic factor. It's the only way we get it, which is the most important protein in our brain for brain health. But many people don't, they kind of think in the general sense, I need glutathione for my immune system to help me from getting a cough or a cold or maybe for something else. But no, we actually need it for our brain. And that's really important. And the other thing that this is sort of cosmetic and not really that important, but it does actually preserve hair color. So, I'm in my 70s. I don't have a lot of gray hair, and I attribute that to the fact that I've been many years actually optimizing my glutathione. I actually have a special solution that I do use on my head to optimize glutathione because it does feed the hair follicles as well. So somebody says to me, "Are you cheating?" Well, yes, I'm cheating a little bit. I do know to optimize the glutathione.
You'd have to give me that formula.
Well,
It's
interesting.
super important topic, super interesting. Again, we don't hear enough about it. When we do hear, it's confusing message. Even I would say sometimes when I ask my naturopathic doctors, to give me some glutathione, if you ask for MD, there's confusion. And, like, yes, taking it as a push in the blood, I thought that was the best way, but now you clarified that. And again, a lot of naturopathic physicians don't even think about it.
No, and your physician won't think about it.
I know.
Because there is no pill,
That's right.
essentially.
But there is one now, but it's more acting as a precursor.
Yeah.
It's helping your body to actually.
But as a doctor, I can't write you a prescription that you take to the drugstore and you get glutathione and it's covered by a medical. So that is a real challenge. But more and more research. So it's the most researched item in the human body. There's about almost 200,000 now articles on PubMed on.
That's huge.
It's more than vitamin C, vitamin E.
Why is it so researched, and at the same time there's a lack of awareness in the public?
It's a really confusing thing to me. Now, just prior to COVID, 2,500 medical professionals from the United States and Canada did write a letter to the FDA and Health Canada requesting that glutathione optimization become standard practice in the medical industry because it's so important, right?
So during COVID, if people had good levels of glutathione, what could have changed?
What's really interesting about that is March 20th, there was an article that appeared in our local newspaper. It was published by the public health officer,
March 20th,
2020, yeah. So just as COVID was starting,
beginning of COVID.
yes, there was an article published in the local newspapers here, encouraging people, where our health officer was encouraging people to optimize their glutathione. By the end of April, you couldn't find that article anywhere. So it was
taken down.
It was taken down. It disappeared.
What a shame.
What a shame. Because
we heard about vitamin D, but that also was it was
vitamin D,
kind of
zinc, a little bit, yes. But yes, glutathione. So there is a product that's available, that's now going to be available in Canada soon, that actually has a patent against 13 viruses. The only reason it didn't have COVID is COVID didn't exist when the patent was applied for. But that's a product they're currently getting an NPN number for Canada. So that is specific for viral infections. And
that's interesting.
Yeah, so the reason they created that was for the Zika virus. And glutathione is very effective at HIV. Dr. Luc Montagnier, who won the Nobel Prize, right?
Montagnier, of course. Passed away. Brilliant man.
Brilliant man. And he, in his book, he wrote a whole chapter on how effective glutathione is in the treatment of AIDS. And he was actually, he was.
I think he discovered it.
He did the research on glutathione and HIV. Yes.
Okay.
And then he wrote his book, and then he was basically, I'm trying to say, he was ostracized by the medical community.
Well, he was during COVID.
Yes.
It's a shame.
Yeah.
He won the Nobel Prize. He was like a.
Yes, and he wanted people to take glutathione. No, nobody would let him say that. So, but there is a product that was patented for Zika viruses, but that in Canada, that product just received a patent recently for 13 different viruses.
That's really encouraging.
Yes. As a treatment, so people understand, like in Canada, when we get an NPN number, there's different classes, right? So there's a class 1 which says I can sell that supplement on the market. Basically, it's the ingredients are safe, whatever. There's a class 2, which is to say that the combination of ingredients are safe. Then there's a class 3 where we can start talking about treatment, right? Where something can be used as a...
You can actually make a claim.
You can make a claim for a treatment, right?
And that's a higher level of...
correct. And you have to supply more information to Health Canada to get a class 3 NPN number. You have to, document some of the research that's been done on the product. So I'm very excited. I do have a new website for people. It's just glutathione/GSH. And GSH is the universal symbol for glutathione. Yeah. So glutathione/gsh.com. On there, they can go, they can read all about glutathione. There's many articles on there, things from PubMed. And if people are going to research, I'm going to just ask them not to go to Google and research glutathione. If you want to research...
Why not?
Well, because the information is out of date.
Or it's going to be, the correct information is going to be buried so far down, I guess.
So just go to PubMed, right? You can just Google PubMed, type in glutathione in the search engine,
Yeah.
and you will get current research even from 2024. So there's real current information, and you can go back many, many years. You can see, you can look up Gustavo Bunis, you can look up Dr. Patricia Conshaven, who's now a British Columbia resident. She's about 87 years old. She still skis. She rides her bike. She's an amazing individual. The last time I visited her, she was really lamenting the fact she had to get reading glasses at 85 years old. And so just an amazing individual. But there's a lot of Canadians that were involved in the research of glutathione. They'll find lots and lots of information on it on PubMed, and it'll be current, peer-reviewed information.
Well, it's nice to see that Canada has been kind of leading the way in that research.
Yes.
It's good.
Yes, we've done more actual clinical trials in Canada than I think any other nation in the world, where we've actually taken cancer patients and optimized glutathione during radiation, during chemotherapy to make sure it was safe and effective. We did one for you.
So you want to be careful that people think we should take antioxidants. Well, the problem with that, as you said very rightly, is that you can actually help feed
That's right.
cancer cells.
And then people forget about this cascade where an antioxidant becomes an oxidant.
That's right.
Right? And so you're defeating, if you're not optimizing glutathione in the treatment of cancer, you're just taking antioxidants, the effectiveness is very questionable because of the cascade of oxidation.
Okay, oxidation. Well, that was very educational, and that cascade of you're talking about here when it comes to free radicals and antioxidants is something people don't think about. So sometimes more is not necessarily better when people go, I take a huge amount of supplements and vitamins every day. However, I'm very careful on how I take them, what combinations and so on. And I think sometimes people have a tendency to take too much of one, not realizing that it can create an imbalance in the system. So, yeah.
I look at somebody like, when a Nobel Prize was given out for the vitamin C, for instance, right? Mm-hmm. Where glutathione wasn't involved. And so, now they're doing 50,000, milligrams of vitamin C.
Well, I've done IVs with 25 grams, 35 grams, 50 grams.
Yeah, a lot of vitamin C. And without glutathione, like you could reduce that spectacularly if you optimize glutathione. In 2019, the Nobel Prize was actually given out for hyperbaric oxygen therapy with glutathione optimization.
Oh, together.
Together. So they were doing their hyperbaric oxygen therapy. But what qualified them for the Nobel Prize was the addition of the ability to control the reactive oxygen species, so you can reduce time, reduce pressures, and still get the same result. So that's a very important aspect of glutathione. And just, it's the easiest thing to do, right? And you can't overdo it because it's genetically controlled.
Is it affordable? How much is your supplement?
Oh, it's like $65 Canadian. How much? About $65 Canadian a month.
So like $2 a day, basically.
Yeah.
That's what you're talking about.
Yeah.
Yeah.
Yeah. And I've seen glutathione supplements that are, $200.
Of course.
And so on. So
it doesn't have to be.
Doesn't have to be. So it's always great to be here. You ask such...
Thank you so much.
I really appreciate your great questions, right? You give really great questions.
Well, there's so much more to come. We have so many topics to discuss. We are going to talk about stem cells. We're going to talk about peptides. We're going to talk about the discovery of the essential amino acid, fatty acid C15. We are going to talk about red light therapy. We need to talk about hyperbaric oxygen therapy. We talk about spirulina. I met one of the experts in the world on the spirulina and chlorella. It's fascinating. So I'm super excited, and I'm glad that we talked about glutathione first, because it seems to be so essential.
Every one of those therapies that you just spoke about will be optimized if people would optimize glutathione along with the therapy. So like the omega fatty acid 15 you're talking about.
C15.
C15. We already know that through our research that we can optimize the effectiveness of the anti-inflammatory part of omega fatty acids. It's very conducive to red light therapy, taking spirulina, chlorella, any of those things. All of those things actually depend ultimately are dose dependent on your glutathione levels. So if you need more of that, it's really telling us that your glutathione.
But you're saying 2 a day, that's all you need.
2 a day is all you need. Yeah, unless you're suffering from something, and then we would look at
Doing more, maybe.
doing more.
Alan, it's a pleasure again. Thanks again. See you very soon again on our podcast.
All right. Thank you for the time. Appreciate it.
Thanks.
Bye bye.